Okay, so you came back. Well, that can't be too bad. Let's look a little bit closer today at using the motion blocks. So here are our motion blocks. So what do we have here in the motion blocks? We have the move block. As the name suggests, it moves the sprite around the stage. We looked at that last video. We've got two turns. We can turn left or we can turn right, and we have an option here for how many degrees we wish to turn. Point in the direction. You have four options in point in the direction, and this makes the sprite face in a particular direction. If it's at 90 degrees, it's facing like it is right now. It's facing to the right. At minus 90, it would be facing left. 0 would be facing straight up, and 180 would be straight down. So just so you can see that, if I do that, so that's going to face to the left. If I make it 0, it will face up. If I make it 180, it will face down. So I like to always start with facing to the right. Okay, next we have point towards, and as the name would suggest, it makes the sprite face towards a particular place, and in this case it's set to be the mouse pointer. With these, the pointing direction, I don't have to use the presets. I could, if I wanted, type in here a number, for example 45, and have it point in that direction also. So you don't have to use the presets, but you can put in your own personal choice if you wish. The next one here is the go-to, and the go-to has two coordinates, x and y, and when you use the go-to, the sprite will jump to that space. You won't see it move, it will just appear in the new place. Remember, we talked about the Cartesian plane, and that's why we're using x and y coordinates. Go to the mouse pointer. Again, this will jump the sprite directly to wherever the mouse was. So if I had the mouse here and I was to run that piece of code, it would jump to exactly where this mouse cursor is right now. Glide is very similar to the go-to. The only difference between glide and go-to is when you use glide, the sprite actually moves across the screen. It doesn't jump, it slides across the screen, which is why we have this seconds here. So this is telling me how long it will take to do the move. So in a slide you would actually see it move like that, rather than just jump from one position directly to another. Change by, the change by x and is also change by y, allows me to have a set jump in my coordinates so that I could just have my program repeatedly changing by 10 each time, so I would have the effect of animation or movement. Setting x or y is the same as the go-tos, except I can just do one at a time. The other thing I have down here, I have a couple more. If on edge bounce, so that sets the sprite so that while it's moving, if it gets to an edge, instead of moving off the edge, it will actually bounce. It will stop and do something. The set rotation is the something that you can set it to do. You can make it stay facing left to right, you can make it turn around, you can have it face up or down. So that's what this set rotation's for. This is very useful for playing games and making games that bounce at edge so that the sprite doesn't fall off the stage and you can't find it. These three buttons down here are checkboxes, and when I turn them on, they will put up here the position. So sprite 1's current X position is 59, and as I move, it will move with it. I can do the same here. So these could be useful for making sure that you're facing the right way and doing what it is you think you're doing. But we don't want those on right now, so we'll just turn them off so that they're not in our way. So we're now going to have a little bit of a look at moving our sprite around, and what we need to remember with our sprite is the Cartesian plane. So I'm just going to change and bring up that Cartesian plane so that it makes a little bit more sense when we look at it. Okay, so here's our Cartesian plane, and you can see the coordinate system here starts at 0, 0 in the center, and we have our y coordinate is a maximum of 180, and down the bottom it's minus 180. X is minus 240 to a positive 240. So we have our coordinates. Now you'll notice we clicked on these buttons down here to find our X and Y position, but if you look down here you can actually get the position of where the cursor is. So as I move this around, it will tell me exactly where that is on that Cartesian plane, so it can be very handy. So if I was to set my go-to here to 0, 0, so 0x, 0y, that should put my sprite here in the center. So I'll just have to do that. 0 and 0. Remember, double clicking in here in this plane executes just that one little thing. So if I double click there, it jumps perfectly to those positions. So we can try the different ones. If I wanted to go to the bottom right hand corner, my X position would be 240 and my Y position would be minus 180. When I double click on there, my sprite will jump down to there. So my bottom left is minus 240 and minus 180. Moves over to the bottom left. My top right would be a positive 240 and a positive 180. And finally, my top left would be a minus 140 and a 180 for Y, putting us exactly where we need it to be. Okay, so now we have an idea of what the blocks are and how we might use them. Let's put them to some use. Let's draw a square on our page. So to do that, I'm going to begin by putting a pen down. I'm then going back to my motion blocks and I'm going to move. I want to move 100 steps, and then I'm going to turn. I want to turn, in this case, right, and I'm going to turn right 90 degrees. When I measure my angles of turn, the angle is always the outside measure, not the inside measure. It doesn't make a lot of difference with a square because the outside angle is the same as the inside angle of 90 degrees. But this will be important when you go to draw, say, a triangle. So that's going to draw my first line and turn. I need to do this again. I could retype all of this, or if you're like me and a bit lazy, I can right click from where I want to go and duplicate it and just paste it on. And if I did that again, I now have my 4 turns and my 4 moves, and hopefully when I double click at the top here we will get a square drawn. There we go, beautiful. Well, that method certainly works, but it does take a bit of effort. What I might have been able to do, instead of using a repeat myself a heap of times, I might have been able to use the control called repeat, and I wanted to do the same thing 4 times. So I could have dragged the repeat 4 times, and then I could simply have put in what I needed to put in, which was move 100 right turn 90, and I should have got the same result as previously. Let's see, I'll run it again and we get exactly the same thing, just a lot less work involved. So that's how we draw a square. Your challenge: can you draw a triangle? Okay, so if you pause the video here now, try and draw a square, test yourself on a triangle, and if you come back and pause it now, come back in a moment and you'll be able to look at the answer for a triangle. Pause it now. Okay, so here's the solution for a triangle, and when I run it, you get a triangle. Okay, so practice those things, have some fun. The repeat in the curriculum is called an iteration. So if you see iteration, that's just a word that means repeating in a program. See you for the next one. Bye.